We live in a world that's just drowning in information. So how do we find the important stuff, the signal in all that noise? Well, that's the big challenge, and data science is the answer. It's really the key to turning all that chaos into clarity and, believe it or not, solving some incredibly complex problems. Get this, 2.5 quintillion. Let that number sink in for a second. That is how many bytes of data we are creating every single day. It's pouring in from our phones, from social media, from this huge web of connected gadgets we call the Internet of Things. It is just an unbelievable amount of raw information. So, okay, with all of this data flying around at a ridiculous rate, how do we possibly make sense of it? How do we find the useful bits in that mountain of noise? Well, that is the exact question that data science was designed to answer. So here's how we're going to break this all down. We're going to look at this new data era we're in, and then we'll get into the roadmap that data scientists use. Think of them as detectives. We'll cover everything from the nitty-gritty of cleaning up raw data to the really cool part, building predictive models. And then we'll see how this whole thing is already changing the world around us. All right, to handle a challenge this massive, you can't just dive in without a plan. You drown. You need a structured process, a roadmap. And honestly, the best way to think about a data scientist is to think of them as a digital detective on the hunt for clues and hidden truths. And this quote just hits the nail on the head. See, the job isn't just about crunching numbers in a dark room. It's about investigation. It's about following leads and hunting for those subtle patterns and clues that are buried deep, deep inside the data. And this right here, this is the detective's playbook. It's the 6-step data science lifecycle. It all starts with understanding the case, or the business requirements. Then you have to go out and acquire your evidence, the data. Then comes processing and exploring that data. And only then do you get to the modeling and, finally, deployment. Let's walk through it. Now, before we get to the cool, fortune-telling part of all this, we have to talk about the groundwork. There is a ton of essential, foundational work that has to be done first. This covers the first 4 steps of the life cycle, and they are absolutely crucial. So every single project starts with a question. Step 1 is just figuring out what problem you're actually trying to solve. What's the business need? Only after you know the question can you move on to step 2, which is acquiring the right data from all the different sources you might need. Okay, now we hit step 3, data processing, or as it's often called, data wrangling. And let me tell you, this is the unglamorous part, but it is maybe the most vital. Raw data is almost always a complete mess. You've got missing values, you've got inconsistencies, you've got weird formats. Cleaning it all up is one of the toughest, most time-consuming parts of the job. And if you don't believe me, just look at this. This chart shows how a data scientist actually spends their time. See that massive slice of the pie? That's not building cool models. Nope. That's just cleaning and preparing the data so it's even usable. It's the ultimate garbage in, garbage out situation. A brilliant model built on bad data is just going to give you brilliantly wrong answers. All right, so once the data is finally squeaky clean, we get to step 4, data exploration. This is where the detective work really kicks into high gear. You start digging in, creating visualizations, and just searching for those first clues, those initial patterns, trends, and hidden connections that start to tell a story. Now that all that foundational work is done, we can finally move on to what most people think of when they hear data science. It's time to build the crystal ball. This is where we create models that can actually help predict the future. So what even is a machine learning model? Well, it's not like regular software where a programmer has to write out every single rule. Instead, you just feed it a massive amount of data and it learns the underlying patterns all by itself. That way, it can make predictions on new information it's never seen before. So how does it learn exactly? You split your data into 2 piles. The training data is kind of like the textbook and homework you give the model to study. It learns all the patterns from there. Then, the testing data is like the final exam. You use it to see how well the model actually learned the concepts before you trust it to make real-world decisions. So we've gone from a messy pile of raw information all the way to a trained, predictive model that passed its final exam. But so what? What does that actually mean for us? Well, let's look at the payoff, because this is where it all comes together. The very last step in this whole life cycle is deployment. This is where the model basically graduates from being a science project and gets a real job. It gets plugged into a live application or a business process where it can start making predictions in real time that deliver actual, tangible value. And the results of this process are, and I mean this literally, all around you, often in ways you don't even think about. When Walmart knows what products to stock before a storm, that's data science. When Netflix recommends your next favorite show, that's it too. When Facebook automatically suggests who to tag in a photo, or Google flawlessly filters spam out of your inbox, that is the data science lifecycle in action. And sometimes the insights you uncover are just bizarre. This is a classic example. By digging through sales data, Walmart discovered that sales of strawberry Pop-Tarts would shoot up by 7 times right before a hurricane was about to hit. I mean, who would have ever guessed that? But the data showed the pattern, and that allowed them to make sure the shelves were stocked. So from predicting Pop-Tart sales to understanding diseases, the data science lifecycle gives us this incredibly powerful framework for turning total chaos into real clarity. And as this flood of data just continues to grow every second, the possibilities are, well, they're endless. So it makes you wonder, what amazing problem are we going to solve next?